Welcome, everybody. But does it scale? This question is pretty often asked in software development, usually by backend people. But recently, I've heard this question regarding to Flutter, mainly by mobile native developers, and rightfully so, because Android and iOS has been around for around 16 years, and there have been really big applications since then. So can we reproduce this thing with Flutter? So we will focus, screensaver. Okay, so we will focus on this question today. First, quick introduction. I'm Tomek.
And I'm Paweł.
And we both work for a bank called Klar. And there has been already yesterday a talk about scaling by Mateusz and Albert. And I need to say that not every Polish person is a Flutter developer that works for a bank and in pair presents about scalability of Flutter. That was coincidence. Okay, so there are really two important things to know about us. We're not the same person, so please don't confuse us. And second, even more important,
It's his slide.
yeah, I don't know why he didn't want this slide. Okay, but before we continue, I wanted to ask you something, because accessibility is really important, and there are plenty of people that really care about it. So question here, do you prefer dark or light mode? So dark, dark, and light?
No, dark.
Okay, dark it is. Okay, so first question is, what is scale? For backend and frontend, scale means something different. And today we will be focusing mainly about scaling up, not about scaling down, because that would be much shorter topic. For backend, we care about users, and because this is hard scaling. If backend wants to scale from 1,000 to 1 million users, that might be difficult. But for frontend, if somebody would go to you and ask you, okay, can you scale from 1,000 to 1 million like Android users? You would say like, yeah, well, sure. In frontend, we're more focused about scaling developers, because if we have more developers, usually we can deliver more feature faster. Okay, so another question is, so maybe not another question, but we know that the more developers we have, the more code we write, but then we have more problems. So proper scaling is about mitigating those problems. Okay, my question is, who should scale? I don't think everybody should scale, because if you're a startup, you want to check if your idea for product is useful and users will be using it. What is always important is ability to change, because if you can easily change your code, you can at some point change it so it should scale. So again, I cannot emphasize it strongly enough that ability to change is really important. Usually in every presentation, you need to have a motivational quote. So this quote really well fits this presentation about scaling. Obviously, I had to have a version for Paweł as well. Okay.
Okay, so let's now talk a bit about brief history of Klar. In 2021, Klar had 4 Flutter developers. They were great, committed. They delivered an MVP of the product. At that point, there were 430 Dart files and 14 test files. Yeah, it might not seem like a lot. 14 test files is quite a low number. However, let's remember that an MVP needs to prove that the product works, that the people like it and use it. If the MVP fails, then you might need to go to the drawing board and scrap all the code. So you need to focus mostly on the features. Did the team think at that point about scalability? Not much. However, once the product proved itself, then a next challenge arrived. The backend team was several times larger than the mobile team. So, despite their biggest efforts, the mobile team could not keep up with the backend as for the feature development. So, the mobile team became a bottleneck. Who is now a bottleneck in your company as for the mobile team? Oh, are you doing Android? Sorry, bad joke, really bad joke. We were a bottleneck, and we were doing Flutter, obviously. So how to solve it? The easiest way is to maybe scale the front-end team. So imagine you're a CTO, you are a co-founder of your company. You hired one developer, and then let's say you want to hire 20 more developers. So the velocity should increase 20 times, right? Not really, maybe not really. The velocity doesn't scale proportional to the amount of the developers. It's not linear. It's more, I don't know, maybe logarithmic. So there are various causes of this. So for example, communication overhead. If you have a single developer that has all the knowledge in their head, then they don't need to have any synchronization meetings. They don't need to share their knowledge that much. And if you have a lot of developers working on exactly the same code base, they might step on each other's toes. Everybody here knows what's merge hell. Also, the lines of code written go up linearly. However, the amount of possible paths in this code grows exponentially. So if you do your regression tests manually, the time that you need to spend on them also grows exponentially. So when scaling, we want to be as close as possible to the blue dotted line. So then we need to invest a lot into scalability. In early this year, okay, let's say January, we were about 19 Flutter developers. We grew a lot. We had 10 times more Dart files and more than 100 times more test files. Obviously, the number of files does not translate to the velocity, but there is a correlation. Currently, the features that would have taken us months before, today, they take us weeks in our subteams. The velocity still keeps on improving because people keep on learning and being more proficient, and we still keep on investing into scalability. So how did we achieve that?
Okay, so as I said, it's really important to be able to change your code. But what prevents developers from changing code? Because if we don't change code, it starts to be outdated and it rots. So what stops us? Fear. Fear from breaking stuff. Thankfully, in software development, we have a good tool for reducing this fear, like testing and testing all. So let me tell you something about how we decided to test our application. As you remember, Paweł mentioned that in the beginning we had 14 test files. All of them were integration UI tests. Integration UI tests are really nice for checking elements on the screen if they're existing, plus verifying entire flows. What they are not good at is checking if the fonts are correct, colors are correct, and so on. So our first step was to, for every state of our UI, make a screenshot during the time when we ran those tests. So, like, we created first screenshots and also a static HTML, so we can quickly go through hundreds of screens at once. Because, for example, if we wanted to see how our application looks when the size is increased by 40%, we just run all the tests with this increased size. So instead of going through every screen, clicking around, and obviously we wouldn't find all the screens because different backend data and so on. And this way, within like a minute, I can go through like hundreds of screens to see more or less if everything is okay. Additional advantage of that is when product person goes to us and asks, okay, we implemented this feature 2 years ago. How does it look like? So we're like, let me just send you some screenshots that are auto-generated on our CI. So like really useful tool for us. Some people are using golden tests for this thing. And like there were already plenty of talks about golden tests. And in our case, we don't use them to test entire screens because like, if even a pixel changes in padding, they will fail. And I can live with 1 pixel being dead in padding. So what are those good for? They're really good for render objects. So if you create your custom render object that paints something, or basically custom painters, they are really good to test that. Because widget tests are not so great to test like render objects. So we have much fewer golden tests, and they don't break often. And lastly, widget tests. They are amazing. And who here is a fan of TDD, test-driven development? Okay, if you haven't tried TDD with widget tests, it works perfectly. So please do try out. So apart from trying to test everything, maybe the padding is overkill, like focus on testing fast. So testing frequently, quickly, and also reliably. So let's start with the last one. So if your tests aren't reliable, developers will stop trusting them and say, oh, okay, they are red, maybe next time they will be green. Second of all, frequently. If you're only running your tests like nightly, you have entire backlog of entire day of commits to check because any of them could have broken those. And lastly, they need to be fast because if you are running those tests on every PR and they take like 1 hour, it will block developers and it's extremely annoying. So this is really important.
Meanwhile, maybe we can change to the light theme. Okay. Dark theme people already had their portion, then...
Okay, light theme people.
Okay. So I wanted to talk a bit about design system. However, there were already at least 4 talks about design system. There is one running in parallel, so you all know everything already about design system. So I just wanted to mention some lessons that we learned when implementing Clar design system. So, design systems are really complex. Implementing them from scratch might take a lot of time. So I would really recommend picking an already existing mature design system as a base and then expanding on it. So let's say Material or Cupertino for mobile, there are plenty others. I bet that the designers will really thank you when you provide them already existing polished documentation for those design systems. Avoid exceptions. At one point, I bet you that your designers will come to you and ask you to implement one screen that has different colors, different fonts, basically not fitting into design system as an exception. So there are a few ways of how to handle that. First is to basically ignore the design system, hack it around. The product will be happy because you provided the value really fast. The designers will be happy. However, in the future, it will create problems. Because if you want to have a dynamic color scheme, for example, to implement dark theme or holiday special, then this one part of the application will stand out like a sore thumb. Another way, it is to what to do? It's to reject the changes. Tell the designers that, okay, sorry, we don't support it. You need to do it as we want. And then the problem is that designers might be unhappy because you don't help them fulfill their visions, and then they will think that the developers are just lazy. And the other way how we can do it is to integrate the new change into the design system. It will take more time, however, it will not cause problems in the future, and then you will prove to the designers that you can work together. And then, if you listen to your designers, they will listen to you. The collaboration will be way better in the future. And actually what Martin was talking about, avoid complex components. If you want to have a reusable component, please make them as simple as possible and well parameterized. If a component is immutable and really complex, then your developers will be copying it around, modifying. Nobody will like that. If you need state management within your components, please try to use the built-in default Flutter state management. If the component already needs something like Redux, Block, Mobex, or anything like that, then probably the component is already too big and too bloated. Flutter is an example, a great example of a collection of small, reusable, polished components. Please look at the Flutter code. And then it's really useful when all your designers and all your developers know the design system. With well-defined and documented design system, the developers will be able to implement small screens without the interaction with the designer team. And then the design team can go somewhere, do some more interesting creative work, and then you reduce the dependency on their team. Probably you don't have, at this point, enough designers anyhow.
Okay, next thing, let's talk about code structures. Like, I believe there are here plenty of Android developers that have been doing Android for a long, long time. So who here remembers this structure that we kept activities in activity folder, controllers in controller, models in model? Anybody? Oh my, oh. We suffered so much. Thankfully, now we are moving away from that. We are keeping, for example, files by feature. So all the activities, controllers, and models in logging folder. Hopefully, like now, we are Flutter developers, so we don't do it. So this was really good solution because we should keep together things that change together. And additional, there are a couple of other benefits. So let's talk about Clar and how our file structure looks like. So like this number, 187, is the amount of our Flutter and Dart modules inside our monorepo. And we have three main types of components. App, which is basically standalone applications. Features, obviously there are the features, for example, credit, debit features. And if we scroll down, we have shareable components, like analytics, charts, clocks. And let me quickly explain. So so features, you probably understand how they work. But those Clar analytics and so on, we can share them between both these Clar modules and feature modules. But we don't mix feature modules with each other. So we don't import one feature module into another feature module. Okay, but this is not the entire 187 components, so modules. So what else we have? So in feature modules, we have first this example module, which is basically a Flutter application that is used for two purposes. First, you can run this feature as standalone application. There will be some mocks, because again, it's only part of the application, but you can use this feature. Second of all, we have all UI tests in those examples. So if we want to see all the UI tests, run all UI tests for credit and see the screenshots, we run tests from this. And obviously, all the modules have their own widget tests as well. And the page objects is basically page object that we share between other components if they need to. Also, additional thing, if we go to this Clar, we have this test utils, which is test module that have like mocks, in this case for analytics, because if we want to use this like interface of analytics in other tests, in the other modules, we want to have like some nice mocks already. Okay, so this is our structure, and you might ask, like, do they hate themselves? Like, why do they have so many modules? Can they have like one single like module with all those folders? We will be talking about that. Okay, and those are two really important packages for us, Melos and Mason. There have been so many presentations about Melos, so probably you will kill me if I repeat myself again or other people. So hopefully everybody knows what is Melos. But Mason, it wasn't mentioned so often. It's like templating library. Because if we wanted to create yet another feature module, and feature module consists of plenty of code, tests, repositories, like qubits, screens, like they would be empty, but like to create one single feature module, it would take a lot. But with Mason, you have like template folder with like placeholder, and thanks to that, creating another module with like, I don't know, MFA module would be basically 3 minutes of time. It would be completely empty with nice placeholders, but much faster than before. So Mason is an amazing tool.
Okay. Going through a checklist when releasing your application to a store is a perfectly fine option when you release for the first time, because this process gets tedious with time. The checklist grows a lot, and the product will ask you to release much more often. So also bugs happen, and you will need to release some unscheduled hotfixes. And it's certainly not fun when you are the release person and you are woken up in the middle of the night to create a release for a really critical bug fix. At Clar, 2 years ago, entire release might have taken an entire day of a single developer, and this does not scale. As the project grows in complexity, manual processes become impractical and really time-consuming. Why would you let a human do machine's work? Please do automate when you want to provide long-lasting business value. Those will be a few examples of automations that we did at Clar. So it is really crucial that the release creation trigger can be used by anyone at any point in time. Having a single person responsible for this release management can block entire application if this person goes for a holiday, parental leave, or gets sick. We really want to be consistent here. It's quite simple to do using GitHub Actions, Docker, Mason, Melos, Fastlane. Use CodeMagic, they are amazing. You should be looking for problems that require automation. In our case, we had design system version 1, which was the old one, and we wanted to move to the design system version 2. And those two design systems were incompatible, so we needed to move screen by screen. And we probably already had 100 screens. Not too many, but it's enough. And how can we verify that we move the entire application or a screen to the new design system properly? With automation. We already had those UI integration tests making screenshots on each and every screen. Then we could run this whole suite with design system version 2, inject a single color scheme which was only orange debug color. And then, from the screenshots, we could see if a screen had been properly moved to the design system version 2 or not. So this is an example of it. As you can see, or you cannot see, it's just an opaque orange color. So those screens were properly moved. Screens that were not properly moved or not moved at all might look like this. So the first screen, something is okay with the the text. Okay, it's the good color. And at the last screen, it's almost all opaque, but you can see some artifacts. So still there is a problem. So yeah, you would need to go through all of them. However, it's quite simple to just collect all the screenshots, extract a histogram of colors, see the percentages, and if there is any color different than this orange one, we just report it and fail the test. So it's fully automated, it runs nightly, and we know which screens are not yet moved. Perfectly fine. Oh, by the way, all those screenshots and all our integration tests are running on Linux as Linux applications. We don't, in this case, use simulators, emulators. Why? Because A, it's really easily Dockerizable. Then those applications take really a small amount of memory. They don't need entire emulation stack underneath. They are much faster. They use much less CPU. They are less flaky because of those things. And we need much less powerful runners to do all of this. And of course, we can always scale our application by dragging the edges of the window. If you are checking for colors, checking for translations, then use the tool that is fit for the job. But sometimes you won't have the tool, and you will need to create one. Bash scripting is a great way how to create small command line utilities. However, not every developer works with Bash on the daily basis. Please raise your hand if you remember how to iterate over a list in Bash. Amazing. I don't remember.
I think there were 3 people.
There were 3 people. Good, Ilya. Was it what you thought? So this is something like that. It's not much different than Dart, but it's like that. Who remembers how to iterate over a list in Dart? Raise your hand. Perfect. So you can combine both, but as you can see, more people know how to iterate in Dart. Implement more complex logic with Dart. You can mix it with, of course, with Bash scripting, and it will be much easier to implement, easier to test, easier to maintain, because everybody of you know how to write Dart. So, continuous integration, my favorite topic. So, continuous integration is the practice of merging all developers' working copy to a shared mainline several times a day. So, if you have 20 developers, you can expect at least 20 changes to trunk, master, main, or whatever else you are using a day. But it's not uncommon that a single developer creates 10 commits a day when you are doing CI. So it's 10 times 20, it's hundreds of changes to the main line each and every working day. So building and testing the whole application can actually even take hours when you have a medium-sized project. If you are using pull requests or merge requests or whatever, then those checks must be fast. How fast? I would say under 5 minutes per check. So it is quite hard to achieve that, because in order to achieve that, you need to apply some neat tricks. One trick is to test only changes that were introduced. Melos can help you with that. It can detect which module has changed since the branch was changed from main, and test only those changes. The other example is sharding. So you can cut your tests in shards and run them on different executors at the same time in parallel. If you want to speed up your tests, you just shard it more and then run them on more executors. So this was the first step of a continuous delivery pipeline or process. Dave Farley calls it the commit stage. As you might have noticed, if we want to go under those 5 minutes, we need to apply some tricks, and we certainly won't be able to test all the code. So we need to have, after those checks, 90% of certainty that we didn't break anything. However, then we have 10% of certainty that we broke something. And actually, Dave Farley has amazing blogs. He is really specialist on continuous delivery. He has an amazing blog and amazing YouTube channel, and he can explain how to deal with this much better than I can do within 40 minutes. I will give you some time. One other really important thing is you build it, you run it. Your CI pipeline is an integral part of delivering your application. So you are the team that cares the most about delivering your application to the users. Nobody else cares as much, and nobody else knows your problems as well or your requirements. So if you can, please own the entire CI/CD pipeline. Develop it yourself. You will decrease the dependency on the SRE or DevOps teams, and you will speed up the process of CI development. So what issues we had? Actually, we talked with Mateusz from Lean Code. They have similar issue. It's analyzer. So if you open your IDE and open your entire project, basically, the analyzers want to analyze each and every module, and it consumes copious amount of memory. On my machine, it takes something like 20 gigabytes. It is because, thanks to Mateusz, he explained me that it is because Dart analyzers create a copy for each and every module of the Flutter framework. So obviously, it's a lot of memory consumed. So the only workaround that we have is to open just the feature modules and modules that we are working on, and then it works perfectly. But otherwise, there is no workaround so far.
Okay, so what is the conclusion? Does it scale? Yes, so far. So for us, with these 187 packages, like, it works. We are really happy with that and with our CI. But if we will grow 10 times in size, we will need to probably tackle new problems. But for now, we are pretty happy. Next, CI is a must. If you have small project, you should have CI. But the bigger the project gets, the more stable CI you need to have. Because if you don't have good CI, you won't be able to scale. And lastly, embrace the change. Make it as simple as possible to change your code, to introduce new feature or refactor. So those are the most important things that we learned in our project. So yeah, that would be all.